These are the notes for the set of 6.3. There'll be two notes for the set of 6.3. This first one deals with the directions of reflecting a point over a line. So we'll do an example. We have point A and we have line K, and we're asked to reflect A over K. So we need to remember a few things. We need to remember that the relationship between the line that goes through A and A prime is going to be perpendicular to K. So let's write that down. The line A prime is perpendicular to line K. So I need to look at slopes. So let's look at the slope of line K. So slope of K equals, and it looks like I have a negative slope. I'm going down, and I'm going down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. So I have a slope of -1, which means that the perpendicular slope is going to be +1. In this case, the reciprocal is a little misleading because the denominator here is 1. So 1 over 1 flipped is still 1 over 1. It's the sign that changes. So now that I know the slope of the line that goes through A and A prime, I can draw that line. It goes through A, so I can draw the line that has a slope of 1 through A. So draw the line through A that has a slope of 1. So I place a couple of dots here so that I can see that lovely slope. And there I have that line. So this whole conversation was really about getting down to this step, which is to draw the line through A that has a slope of 1. The other thing that I know is that the distance from A to line K, the line of reflection, and from the line of reflection to A prime has to be the same distance. So first I know that these have to be perpendicular. The other thing that has to happen is that the distance again from A to the line K and from the line K to A prime has to be the same. So in this case, I'm kind of looking at this, and this is really nice that the slope was 1 because it means that I go straight through the diagonals. I'm not going through just a little portion of the box and a different size in the next box. It's actually straight through the diagonals. So from line K, I go 1 diagonal, 2 diagonals, 3 diagonals. And so I'm going to do that from line K, but to where A prime should be on this side of the line. So 1 diagonal, 2 diagonals, 3 diagonals, and there is A prime. So the second piece here is that the distance from A to K equals the distance from K to A prime. And our method here in this case was to count. And that won't always work, but for now that's the method that we're going to use.